Hello class, we are looking at the chapter 1 study guide. If you go to Blackboard and you click on study guides, you will see the questions that I'm about to go over on our online notes. Very important that you study your vocabulary and you study your directions for each section. Also on test day, you're not allowed to use calculators, but you can use a timetable sheet. So print you out a timetable sheet and bring that on test day. But you cannot use a calculator. Very important. I am on page 12 looking at section 1.1, and we're going to start with number 70. Section 1.1 talks about real numbers and their graphs. Number 7 says, graph each set of numbers on a number line. Use brackets or parentheses when applicable. On number 70, it says the odd integers between -5 and 5 that are exactly divisible by 3. We know that odd are numbers 1, 3, 5, 7, 9. Those are odd numbers. We know integers are positive, negative whole numbers, and 0. And we know when it says divisible by 3, think about those 3 timetables. 3, 6, 9, 12, so forth. A number line is horizontal. And looking at the information that's given from the book, the number line went from -3 to +5. So on my example, I'm going to do a little different. I want to see what numbers are divisible by 3. And if we think about our numbers from -5 to 5, I know that if I think about my 3 timetables, I know that 0 works. We have 3 times 0, give me 0. We know that 3 times 1 is 3. And we know that 3 times -1 is -3. My answers, I do want to plot those points. I want to plot -3, 0, and +3 because those 3 numbers are divisible by 3. Look at number 73. 73 says the odd numbers from 10 to 20. If you look at your number line again, we're going from 10 to 20, and they only want me to plot the odd numbers. So we're going to graph the odd numbers from 10 to 20. So we're starting at 10, and we're ending at 20. So what are my odd numbers between 10 and 20? From 10 to 20. I know that 11 is a number. I know 13 will work. I know 15 will work. I know 17 will work. And then finally, I know 19 will work. And then just space it out so that way you can make sure everything is nice and neat. I'm going to apply 11, 13, 15, 17, and 19. So those are the points that I want to put on my number line to satisfy my question. Look at 125. 125 is a little different. It says graph each set of numbers on a number line. Use brackets or parentheses when applicable. 125 says the real numbers greater than or equal to -5 and less than 4. Let's talk about those signs again, those inequality signs. We know that our less than sign goes this way. Greater than goes this way. Less than equal to, greater than equal to. We also know that when I see less than, greater than, that is an open circle, or they are parentheses. And when I see less than equal to or greater than equal to, it's going to be a closed circle or brackets. Very important that you know that. Let's look at 125. I'm going to just draw me a number line. And the question says greater than or equal to -5. So my key number is -5. Sometimes it's good to put 0 there so you can distinguish that the negatives are to the left and the positives are to the right. And then we have less than 4. We want to plot 4 on our number line. So our key numbers are -5 and 4. It says greater than or equal to. That will be a closed circle on -5. Greater than, we're going to start shading to the right, but not too much. We have to read the rest of the problem. It says and less than 4. It says just less than. So it will be an open circle, and we're going to shade to the left because it's less than. And that is what my graph will look like. If I do it with the parentheses and brackets, we will have -5, 0, and 4. A bracket at -5. And you want to turn the bracket in the direction that you're going to shade in. And turn the parentheses in the direction you're going to shade in as well. Open circles, we use parentheses. And then we shade in between. Usually when I see the keyword and, the graphs are going to look something like this. They're going to compound. So when you see word and, you think about a double inequality or a compound inequality. When you see the word or, usually they shade away from each other. So usually when I see and, they come together. And when I see or, they usually shade away. In some cases, it might not do that. But most of the time, that's the way the graph looks. And again, you have to pay attention to your inequality signs. So that is it for section 1.1. We're going to now move to section 1.2. So turn with me to page 26. And we're going to look at number 74. 74 says, perform each division. Simplify each result when possible. I have 3/8 divided by 15/28. We are dividing fractions. To divide fractions, keep, change, flip. You are multiplying by the reciprocal. Keep, change, flip. Keep, flip, change. Or kiss. Keep it, switch, switch. But all those acronyms are just telling me to multiply by the reciprocal. Now, before I do any work, before I start multiplying, I do want to simplify these numbers as much as possible. So let's do that. I can simplify 3 and 15. When you simplify, make sure one is in the numerator and one part is in the denominator. So it can be up, down, or the angle. But one has to be in the numerator and one must be in the denominator for me to simplify. 3 is at the top, 15 is at the bottom. I can simplify. What can I pull out of 3 and 15? I can pull out a 3. So 3 goes into 3 once. 3 goes in 15 5 times. Now let's simplify that 8 and that 28 because it can be simplified also. So think about 8 and 28. What can I pull out of 8 and 28? Well, let's start with, we can start with 2, or we can go up a little higher and do 4. So I want to find that greatest common factor, which will be 4. 4 goes into 8 2 times. And then 4 goes into 28 7 times. Now, if you don't like that, just do it one step at a time. Let's do a rewrite so we can see what's going on. I have 1/2 times 7/5. Can I simplify anything else? I can't simplify anything else. So now you multiply straight across. 1 times 1 is 7. 2 times 5 is 10. And my answer is 7/10. 92. 92 says, perform each operation, simplify each result when possible. So for 92, I have 15 and 5/6 plus 11 and 5/8. So that worked with some big numbers. So you do have to kind of be careful with the big numbers. Take your time. Now, one thing you can do is you can convert this mixed number into improper fractions. Find your common denominator, then clean it up from there. Or just try to work it out like it is. I'm going to work it out the way it is. I have 15. I need to figure out what is a common denominator for 6 and 8. Now, when you're finding your least common denominator, it needs to be either the largest denominator or a number bigger than all the denominators. So you have to ask yourself a quick question. Can 6 go into 8 and get a whole number answer? 6 can't go into 8 and get a whole number answer. So that's not going. 8 is not going to work. 8 can go into 8, but 6 won't go into 8. I can't use 8. I need to find something bigger for 6 and 8. Now, when in doubt and you can't figure it out, just multiply 6 times 8 together. And then you'll have a common denominator. It may not be the least, but it will be a common denominator. So really quick, we have 6 and 8. One thing you can do is start just doing your timetables until you find a number that they have in common. So that timetable sheet will be very useful in what you're trying to do. And then if you find something in common, you can stop. So I see that if I use 24, that's the first number that 6 and 8 have in common. So my least common denominator for 6 and 8 will be 24. Now, how did I get to 24 on both of these? So to do 6, I got 6 times 1, 6 times 2, 6 times 3, 6 times 4. So I have to multiply by 4 to get 24 here. Now, how did we get to 8? We have 8 times 1, 8 times 2, 8 times 3. Times 3 to get to 24 here. What I said that 6 goes into 24 4 times. So 5 times 4 is 20. Okay, go to the next fraction. 8 goes into 24 3 times, so 5 times 3 is 15. Now let's add everything up. I know that 15 plus 11 is 26. Add up that 20 and that 15. 20 plus 15 is 35 over 24. Now this problem looks bad because it looks like a mixed improper fraction. Now we know we don't have a fraction that's named mixed improper. We have to fix this. I have 26 whole numbers, but I have 35 over 24. I can break that up some. I know that 24 out of 24 will give me 1, but I need the numerator to add to be 35. So once I've pulled out 24 of them, what's remaining? If I say 35 minus 24, I get 11 out of 24. So one more time, I'm going to say 26 plus, I know 24 divided by 24 is 1, plus 11 over 24 again. So my final answer would be 27 and 11 over 24. Again, if you don't like that, you can easily turn it into an improper fraction and work it that way and then simplify it back to 27 and 11 over 24. That's another strategy. The only downside about that is the numbers are going to be very big, that you have to do really large numbers, but it does work. Let's go to section 1.3. And in section 1.2, it talked about dealing with fractions. 1.3, we are getting into exponents and order operations. We must remember PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. When you're multiplying and dividing, it's a rule within that rule. If you have multiplication and division one behind the other, you work it from left to right. It doesn't matter which operation will come first. If multiplication and division is put together, you have to work from left to right, and the order doesn't matter. Just start from left and finish it to the right. That rule also applies with addition and subtraction. When you see addition and subtraction put together, you work out the operation from left to right. So that's that rule within that rule. You have to be very careful and make sure you do. On section 1.3, let's look at number 39. It says, and I'm on page 36. It says, write each expression without using exponents and find the value of each expression. For number 39, I have -1/5 raised to the 4th power. When you're working problems out like this, it's very important to identify the base and the exponent. My base is -105 because it is in parentheses. And my exponent is 4. So I write it out 4 times and I multiply. When in doubt, multiply. Multiply all the numerators together, then all the denominators. I see 4 negatives. So going into our rules for multiplying and dividing real numbers, I know a negative times a negative is positive. Positive times a negative is negative. And then a negative times a negative again is positive. So my overall answer is going to be negative. So I'm going to be positive. I have 4 negatives. 4 negatives give me a positive answer. I know 1 times 1 times 1 times 1 will be 1 still. In my denominator, multiply 2 numbers at a time. We have 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So my answer is 1 over 625. When you multiply, if it's 1, you know, I don't care how many times you multiply 1, it's going to still be 1. But when you're dealing with something that's not 1, multiply 2 numbers at a time so you will not mess up that final answer. Number 76. Number 76. It says find the value of each expression. I have 2 times 5 squared minus 2 squared plus 3 divided by 2 times 5 minus 2 squared minus 11. So we have to do our order of operations. As you work this problem out, simplify a little in my numerator, simplify a little bit in my denominator, and then repeat the process. Your goal is to get to one single number in my numerator and one single number in my denominator. Or you might just have a whole number answer, an integer answer. Let's work this problem out. In my numerator, I see no parentheses, but I see exponents. So exponents go first. 2 times 5 is 25. Minus 2 times 2 is 4. Plus 3. Now work a little in my denominator. In my denominator, I see parentheses and exponents. So I want to start with parentheses. I have 2. 5 minus 2 is 3. Squared minus 11. Next step. Look at my numerator. Work a little bit off the top again. I do not see any parentheses. No exponents. I do see multiplication. 2 times 25 is 50. Minus 4 plus 3 divided by, in my denominator, I see an exponent. Right here, parentheses means is a grouping symbol. But parentheses also can be used as a multiplication in the operation of multiplication. So very important that you distinguish which one this is. I see 3. It's just 3. There's nothing else in there. So that is done. So I see 3 squared. If it's in a group, we know a group means 2 or more. So if it's in parentheses and I see multiple numbers, values in there, I need to get down to one number. And then I can go to that next step in my order operation. So make sure you're very careful with that. I see 3 squared. 3 times 3 is 9. And I can do parentheses or a dot to indicate multiplication. minus 11. Now, keep working. We have, notice here, you see in my numerator addition and subtraction, one behind the other. That's that rule within that rule. I need to go from left to right. We don't want to say 4 plus 3 and then take that result and say 50 minus the result. Do not go in that order. Go from left to right. So we have 50 minus 4 plus 3 is 49. Now what would have happened if you said 4 plus 3? Of course you said 4 plus 3, you might get 7. You might get -1 if you don't pay attention to your sign. So you might mess that up. So very important that when you add and subtract and it's one behind the other, you go from left to right. And that way you won't mess it up. Keep it very elementary. 50 minus 4. And then take that answer and then add 3 to it. It's done. Keep it very simple. 2 times 9 is 18. Minus 11. So keep working a little bit. 49. And what is 18 minus 11? It is 7. Divide those numbers. I get an integer answer, which is 7. So that is it for section 1.3. Let's go on to section 1.4, adding and subtracting real numbers. Let's turn to page 45. And we're going to look at number 44. 44 says, evaluate each expression. -27 plus -12 plus -13. Okay, right here you still want to think about those order operations, but you also need to think about adding and subtracting real numbers, adding and subtracting integers, because you do need to apply those rules to 44. Bring down your -27 plus sign. Now let's work in those brackets first. I have -12. I know that a negative times a positive. When I see a sign times another sign, go ahead and multiply together and get one sign. So a positive times a negative makes a -13. -27 plus. Now if you look at 44, look at the bracket. I see -12 minus 13. So the signs are the same. The rule is that when the signs are the same, you add and keep the sign. If I add, I'm going to get 25 and keep the sign as -25. Now look at my last step. I see -27 plus -25. These signs are the same, so I still add and keep the sign. So my answer will be -52. Let's go to number 74. Looking at some more fractions with some signs, positive, negative signs in it. It says simplify each expression. I know that this is an expression. Because I don't see an equal sign. Now we know that an equation, I'm going to see an equal sign. And we know that equations, we also see equal signs, we see variables, we see all kind of stuff going on with the equation. Very important as you study, make sure again you're looking at your vocabulary in each section, you're studying your directions, all those things. So make sure you're doing all these things. Okay, look at number 74. Now right here, I see in my first parentheses, I need to find a common denominator. So my common denominator for 3 and 6. Again, think about it. Look at the larger denominator. Can 3 go into 6? Yes. Can 6 go into 6? Yes. That's my common denominator, 6. 3 goes into 6 2 times. 2 times 7 is 14. Minus 6 goes in 6 one time. 5 times 1 is 5. Minus. Now we want to work out this part. I want to do a little multitasking here. My common denominator for 3 and 6 is still 6. But I also know that a negative times a negative makes a positive in the middle. So I did 2 steps. I found my common denominator, and I know that a negative times negative make a positive. At the first step, we know that 6 goes in 6 one time, then 1 times 5 is 5. 3 goes in 6 2 times, and then 2 times 7 will give me 14 again. So a lot going on here. Now let's do our math. In the first parentheses, I know 14 minus 5 will give me 9 over 6. Minus, in my brackets, I know that 14 plus 5 will give me 19 over 6. Right here, this is really good because the denominators are already the same, so I can go ahead and combine those together. 9 minus 19 is negative 10 over 6. We want to simplify that by 2. 10 and 6, negative 10 and 6 are divisible by 2. My answer would be negative 5 over 3. Let's go to section 1.5. And 1.5 talks about multiplying and dividing real numbers. So before I go into 1.5, I do want to go over adding and subtracting real numbers. Let's talk about those rules again. And I'm on page 53. So let's talk about the rules first. The rule is that when you're adding and subtracting real numbers, when the signs are the same, you add and keep the sign. And when the signs are different, you subtract and keep the sign of the larger number. Now, a student of mine did an excellent triangle to help us remember those sign rules on when we do our multiplication and division. We have 2 negatives and we have a positive. If you think about the triangle, a negative times a negative will give me a positive. A positive times a negative will give me a negative. A negative times a positive will still give me a negative. So think about that triangle. These rules also apply with dividing real numbers. When you're multiplying and dividing real numbers, think about that triangle. Match up 2. The third symbol will be the sign that you need to use. Very important. And again, think about it. We are working with 2 numbers at a time. So make sure that when you apply this triangle rule, you're applying 2 numbers at a time. It works with 2 numbers at a time. Very important that you pay attention to that. Let's look at number 70. Number 70 says perform each operation. When you hear the word operation, I'm asking you, are you going to add, subtract, multiply, or divide? When you hear that one word operation, are you adding, subtracting, multiplying, or dividing? So make sure you remember what that word means. Also, we want to make sure that on this problem, we're following the order of operation. So you still have to apply the order of operations. When I see multiple things going on, I see some addition, some subtraction, some division, exponents, parentheses, brackets, whatever I see, I need to remember I have to apply my order of operations. So on number 70, we want to work a little off the top, a little off the bottom until we get down to that final answer. In my numerator, I know that 2 times negative 25 is negative 50. And then negative 50 times 10 is negative 500. So we got some big numbers, but take your time and multiply it out. We got negative 50 times 10, which is negative 500. But notice I did 2 numbers at a time. Multiply the next set of numbers. 4 times 5 is 20, and 20 times negative 5 is negative 100. And don't be afraid. Don't let the plus and the negative sign throw you off. It's not a big deal. Just leave it. In my denominator, I have 5 times 125 minus 25. We know it's 100. Okay, keep working. Now, in my numerator, the signs are the same, so we know to add and keep the sign. In my denominator, I know that 500, 5 times 100 is 500. If you know anything about the zeros, cancel out those zeros. That works with zeros only. My final answer is negative 605. And remember, when you do that canceling out like that, it only works with those zeros because, zero's nothing. So make sure you keep that in mind. Very important. My answer is negative 6/5. Okay, so we're almost there. We're on section 1.6 now. Page 59. Looking at algebraic expressions. I'm starting off with number 23. Keywords to think about. What words come to mind when you deal with a plus sign? And then a minus sign, a division sign, and a multiplication sign. What type of words come to mind let you know that it's addition? So I may hear the words more than, some, things like that. Plus, all that. Those, we know that means add. When I see subtraction, I might think about the words the difference, less than, minus, take away, subtract this from this. We know those keywords let me know that that's subtraction. Division. We know a new word, a lot of words you don't use that often. Division, you might hear the word quotient, divided by, things like that. Multiplication, we'll hear the word product, twice as much, 3 times as much. Keywords like that we'll see when we talk about multiplication. So very, very important. On number 23, it says the number that is 3 less than x. Right here, that word less than, it means you write the first part last and the last part first. So let's read again. It says the number that is 3 less than x. But the way you write it is x minus 3. When I see less than, more than, from, I write the first part last and the last part first. Very, very important that you pay attention to the words more than, less than, from. First part last, last part first. And the rest of them, for the most part, you just write it the way you read it. Look at number 39. 39 says, evaluate each expression if x is 2, x is negative 2, y is 5, and z is negative 3. Okay? So on 39, I have 4, z squared, y, and that's all multiplied together. When in doubt, multiply, divided by 3 times x minus z. We are substituting the numbers in for those variables. I have 4. Where my z is, I'm going to input negative 3. And then I'm going to square it. Where y is, I'm going to plug in. I'm going to substitute with 5. Divided by 3. Where x is, we're going to substitute x with negative 2. Bring down that minus sign. And then where z is, we're going to substitute that with a negative 3. And if you want to, you can put that in parentheses as well. Take your time and work this out because I see so many different signs going on. In my numerator, I see parentheses and exponent. In parentheses, you see a single value in those parentheses. So I'm not grouping it with nothing. So let's go on to the next step, which is exponents. We have 4. Negative 3 squared is negative 3 times negative 3, which we know is 9, times 5. In my denominator, I have 3 times negative 2. Now right here, be careful because a negative times a negative makes a positive 3. So take your time and write that part out. In my numerator, multiply 2 numbers at a time. 4 times 9 is 36. Times 5 is 180. In my denominator, I have 3 Keep it very elementary. 3 minus 2 is 1. Or you can say negative 2 plus 3, or just read it like you always read it. 3 minus 2 is 1. Right here I have 180. 3 times 1 is 3. I know 3 go into 18 6 times, and then I add that 0 to it. My final answer is 60. Number 53. It says, giving the number of terms in each algebraic expression, and also give the numerical coefficient of the first term. So we need to talk about a little bit more vocabulary right here. Let's write the problem down right quick. 53. 5x minus 4y plus 3z plus 2. It says, give the number of terms. The terms are separated by the plus and minus sign. So how many terms do I see? 1, 2, 3, 4. The number of terms is 4. Then it says, give the numerical coefficient of the first term. We know what first is. It's going to be that first term, which is this one. A coefficient is the number part of a factor. I see 5x. The number part is 5. So the numerical coefficient for the first term is 5. And that's it on that one. 83 through 86. It says, consider the algebraic expression. And let's write the expression down right quick. 29 xyz plus 23 xy plus 19x. Consider the algebraic expression and our given expression here. 83 says, what is the factors of the third term? So the factors is what times what gave me the third term. We've already know how to count terms. We have 1, 2, 3. We have 3 terms. The terms are going to be separated by plus or minus signs for these examples. The factors for the first term are 19 and x. So the way you read it is the way you break it up. You say 19x, so 19 and x are my factors. 84 says, what are the factors of the second term? You say 23xy. Write all that down, what you just said. You said 23xy. And that's my answer. 85. What factor is common to the first and third? So look at the first term and the third term. What do they both have in common? Now, when you do this, you need to make sure you pay attention to the coefficients. And my coefficients are 29, 23, and 19. Those are all my coefficients. The leading coefficient will be 29 because that's the first term we see. But all my coefficients, you have to pay attention, make sure they don't have anything in common either. So think about 29 and 19. Do they have anything in common besides 1? They don't. So we're good there. The only thing I see that the first and third term have in common is x. That's it. 86. What factor is common in all 3 terms now? So what do all 3 terms have in common? They all have an x in common. Last section. Let's look at 1.7, properties of real numbers. So again, make sure you look at your vocabulary. Very important. And make sure you study your directions. I'm on page 68, looking at 47. Use the distributive property to write each expression without parentheses. Simplify each result if possible. 47, I have negative 2 times 3x plus y. I'm going to distribute the negative 2 to both terms. Negative 2 times 3x is negative 6x. Negative 2 times y is negative 2y. These are like apples and oranges. The first term has an x, the second term has a y. They have nothing in it. So they're unlike terms, so I do not do anything else to this problem. Leave it alone. Number 50. Y times y plus z. We're going to distribute that outside y to both terms. Y times y, how many y's you see? I see 2 of them. So it's going to be y squared because I saw 2 of them. Y times y is y squared. Plus y times z, just write y times z. That's it. And very important, to get in the habit of putting your variables, which we know are letters, they're letters of an unknown value. Make sure you get in the habit of putting those variables in alphabetical order because that'll help you out when you get into your other math classes. So just get in the habit of doing that. Last example, 66. Place values. That's something you learned back in elementary school. So take a moment and just study back over your place values. We know we have 1, it's in the ones place, 2 in the tenths place, 5 in the hundreds place. So we got ones, tenths, hundreds place. So the 5 is in the hundreds place. And the reason I'm saying that is because I want to do a rewrite. I want to rewrite negative 1.25 as a fraction. I have negative 125 over 100. And I'm going to leave it like that for right now because I'm going to get to that step in a minute. The direction says give the additive and the multiplicative inverse of each number if possible. Now the word inverse means to just undo. So how do I undo if I say, okay, open the door, then to undo that you're going to close the door. So you're just undoing something. If I put on my eyeglasses, I'm going to take them off to undo. So inverse means to undo something. So when I see additive inverse just means the opposite. What is the opposite of negative 1.25? The additive inverse, which is the opposite of negative 1.25, is 1.25 or 1 in 25 hundredths. Multiplicative inverse is nothing but the reciprocal. And we know the informal definition of reciprocal means just to take that fraction and flip it. But it says negative 1.25 is not a fraction, it's a decimal. So that is why on the side, I have negative 125 divided by 100. And if you don't feel confident about that, if you divide, you'll get, if you divide if you say how many times 1 going to 125, you're going to get the 1.25 again. Now, if I simplify this is going to be equivalent to negative 5 over 4. And I tell students all the time, think about money. Think about 100 and 125. How many quarters do I need to get to 100? I need 4. How many quarters do I need to get to 125? I only need 5. Okay? So that's how we got down. We got to simplify down to negative 5 over 4. To do the multiplicative inverse, we're going to take the reciprocal of negative 5 over 4. So all I do is just take the fraction and flip it, which is negative 4 over 5. Do not change that sign. Leave that sign alone. So again, when we say additive inverse, I'm taking the opposite of that value. It's on the opposite side of the number line, but it's the same distance from 0. So I have negative 1.25 on the left side of 0 and positive 1.25 on the right side of 0, but they're the same distance. So opposites is just basically, they have to be the same distance from 0. That's how I figure it out. Same number, different sign. That's it. Multiplicative inverse, you take the number and just flip it. But don't change the sign. Very important that you know that for vocab inverse. Okay, so that is it for our review, and I hope you learned a lot. And please continue studying for your test.